Hey guys, welcome back to another practice question of complex numbers. This is taken from question number 5b of the Nanyang Junior College 2020 Prelims Paper 2. Our objective is to find z minus 2 square root 3 in the form of r e to the power of I theta. And r and theta must be in exact form. So firstly, we can express z in a trigonometric form. So for this case, it is 2 square root 3. Open a bracket, cosine minus pi over 3, because that is the argument, plus I sine minus pi over 3. If you find it difficult to remember the trigo form, always remember C, which is cosine, always comes before S in the alphabet. So cosine comes first and then sine come later. Alright, so simplifying this, we will have 2 square root 3, open the bracket, cosine minus pi over 3 gives us a value of half, minus square root 3 over 2i. We will then have square root 3, open the bracket, 1 minus square root 3i. And this will be equals to square root 3 minus 3i. Now with this, we are going to find the modulus of z minus 2 square root 3. And this is equals to the modulus of square root 3 minus 3i minus 2 square root 3. Simplifying, we'll have modulus minus square root 3 minus 3i. And to find the modulus of this expression, we will have square root 3 plus 9, which gives us square root 12. And simplifying, we will have 2 square root 3. Now the argument of z minus 2 square root 3 is simply the argument of minus square root 3 minus 3i that you have found in the earlier step. And to illustrate this on the Argand diagram, minus square root 3 minus 3 lies on the third quadrant of the Argand diagram. And if we were to find the basic angle, it will be tangent inverse 3 over square root 3, which is equals to pi over 3. Now, since the angle is measured anti-clockwise from the positive x-axis, the argument of z minus 2 square root 3 will then be equals to minus 2 over 3 pi. So always remember to answer to the question. Z minus 2 square root 3 will be equals to 2 square root 3 e to the power of I multiplied by the argument, which is minus 2 over 3 pi. So let's move on to B part 2. We're going to find the 3 smallest positive whole number values of n for which this expression is a real number. Now, not to worry if you see such question. If this is a real number, it means that it lies on the x-axis of the Argand diagram. So let's associate this with arguments. Alright, so the argument of this expression, if we simplify it, will be the argument of z minus 2 square root 3 star minus the argument of z minus 2 square root 3 power n. Now recall the property that you see on the right hand side of the screen right now, which is very useful. To simplify this further, we are going to have 2 pi over 3, which is just the opposite sign of the original argument, minus n, argument of z minus 2 square root 3. Simplifying, we will have 2 pi over 3 minus n multiplied by minus 2 pi over 3. This is the argument that we have found in the previous step. Alright, and this will give us 2 pi over 3, open a bracket, 1 plus n. Now, as mentioned in the question, since this expression is a real number, the argument of this expression is equals to, let's introduce an integer here, which is k multiplied by pi. The pi that you see over here indicates that it lies on the x-axis or the real axis of the Argand diagram. Simplifying, we will have 2 pi over 3, 1 plus n is equals to k pi. Making n the subject, we have n plus 1 equals to 3 over 2k, and n is equals to 3 over 2k minus 1. Now you realize the question wants us to find the 3 smallest positive whole number values of n. So what we can do is we could substitute k equals to 2 into this expression, and this gives us n equals to 2. Now, if we substitute k equals to 1, n is equals to half, and that is not a whole number, which is not what we want. Alright, so moving on, we can substitute even numbers of k, which is maybe k equals to 4, and your n is equals to 5. And if we substitute k equals to 6, n is equals to 8. Alright, so the three smallest positive whole numbers of n are 2, 5, and 8. And we will then answer to the requirements of this question. Now, I do hope you learned something from this video. If you like this video, do hit the subscribe button so that you can see more valuable content such as these. I'll see you in the next video. Bye!